Okay, I'm going to show you a review practice problem for each of the types of problems on your math practice assignment. So the first review practice problem I'll do is net force. So you have a force going in that direction with 8 newtons, and a force going in the opposite direction with 32 newtons. Then the net force of this problem, we know that the direction of the force will always be in the same direction as the highest force under our problem. And so the highest force is 32 newtons. That's going this direction. And so after we combine these two forces, our direction will be to the left. Alright, so when we combine two forces in opposite directions, we always subtract them. When we combine two forces in the same direction, then we always add them together. In this case, they're opposite directions. So we're going to take the bigger one first, 32 newtons, minus the smaller one, 8 newtons. And we get left over 24 newtons of force. So our answer is 24 newtons of force in that direction. All right, the next type of problem we're going to review is a speed problem. So with speed, you need to remember that speed is equal to distance divided by time. So if we had a jogger goes 6 kilometers in 30 minutes, and we wanted to know kilometers per minute. How many kilometers per minute was he going? That would be his speed. We use our equation. Speed equals distance. And so distance is going to be 6 kilometers. We're going to plug that in for distance. Divided by time. Our time is going to be 30 minutes. We're going to plug that in for time. Then we take 6 divided by 30 minutes. And that should equal, let me do my calculator here real quick. Six divided by 30 equals 0.2. Alright, so we got 0.2 kilometers per minute. Make sure you remember to label your units. Okay, each one's going to have a label. Make sure you label them. So that one is speed. Okay, and then we're going to do an example of an acceleration problem. So for this one, we're going to use our acceleration equation. Acceleration equals the change in speed, which is final speed minus initial speed. And divide that by time. All right, so if let's say we have a car is traveling at 35 miles per hour, and it speeds up to 60 miles per hour 3 seconds. And we want to know what its acceleration was. So we use our equation. We're going to use ACC for acceleration. Acceleration equals, we need the final speed. Okay, so it sped up to 60 miles per hour. So that's going to be the final speed, what it ended at. Minus the initial speed. The car was traveling at 35 miles per hour. So we'll plug that in for the initial speed. Divided by time, which was 3 seconds. Okay, so 60, so we take 60 miles per hour minus 35 miles per hour. That should get us 25 miles per hour. We take 25 divided by 3, and that will leave us with 8.3 repeated. And that's going to be miles per hour per second. Okay. So for the last example, we're going to do net force using Newton's second law. So this net force is going to be a little bit different than the other. Newton's second law says net force is equal to mass times acceleration. And sometimes you're going to need this in 3 different ways. Sometimes you might use it in this way, the way it is already. Sometimes you might use the equation to look like mass is equal to net force divided by acceleration. And sometimes you might use acceleration is equal to net force divided by mass. Which one you use just depends on the problem. So let's do one off of the sheet itself, number 1. It says determine the accelerations that result when a 12 Newton net force is applied to a 3 kilogram object and then to a 6 kilogram object. So it wants us to find 2 accelerations, one for each object. So since we're finding acceleration, then the equation that we want is one that says acceleration equals. So that would be this one right here. So we use acceleration equals. And it says acceleration equals net force divided by mass. And this problem says that we want to determine the result when a 12 Newton net force is applied. So for the net force part of the equation right here, we want to plug in 12 newtons of force. And we're doing this for 2 objects, so let's set it up twice. Okay, and then according to our equation, mass is on bottom, so we need to find the mass and plug that in. For one mass, it says it's 3 kilograms. And for the other mass, it says it is 6 kilograms. And then we can just solve those. We got 12 divided by 3 equals 4 meters per second squared. And 12 divided by 6 is 2 meters per second squared. And so those are our accelerations. Now, if it asks you to find net force of an object, then you use net force equals. And if it asks you to find the mass of an object, then you use mass equals. So whatever you're finding, that's the equation you want to use on these problems.